Hello guys, it's our new video and we gonna speak about Rust, programming language such as Rust. And we're gonna start right now. And we're gonna speak first of all about expression blocks. Despite the syntactic resemble to C and C++, the semantics of Rust are closer to that of the male family of languages and the Haskell language. For example, nearly every part of a function body is an expression. Even control flow operators with ordinary if expression also takes the place of uh, KS ternary condition, an idiom used by Angle 60, as in Lisp a function does not need to end with a return expression. If the semicolon is omitted, the last expression in the function will be used as a return value as seen in the following recursive implementation of the factorial function. So guys, you should recollect it in your knowledge and after that we're gonna continue. So let's continue. Unlike other languages, Rust does not use null pointers to indicate a lack of data, as going so can lead to accidental dereferencing. Therefore, in order to uphold its safety guarantees, null pointers cannot be dereferenced unless explicitly declaration of the code block and save with an answer block. Rust instead used a Haskell-like option type which has two variants: "T", which indicates that a value is present, and "none" alone goes to the null pointer. Option values must be handled using syntactic sugar such as the if-let construction in order to access the inner value in case a string. Generics. More advanced features in Rust include the use of generic functions to achieve type polymorphism. The following is a Rust program to calculate the sum of two things, for which addition is implemented using a generic function. Generics in Rust use trade bounds for their generic parameters, which precisely define what is required of a type in order to be used with a given generic function. This allows generic in Rust to be type checked, without having to substitute concrete types like C++ template substitution failure cannot occur. Ownership and lifetimes. Lifetimes are a usual implicit part of one reference starts. Each particular lifetime encompasses a set of locations in the core. A lifetime is said to outlive another if it is valid in at least all locations of the later. The border checker in the Rust compiler checks that for all references use their reference. The values referred to outlive their references. It also ensures that immutable performances only exist if no immutable references exist at the same time. Due to these checks, the following examples do not compile. Rust users um, uses a ownership system where each value has a unique owner. Values can be moved between different owners, which is similar to move semantics in C++. However, unlike C++, the compiler keeps track of moved values. This means that types in Rust do not have to implement an empty or invalid state to signify that a value has been moved out of, because using a moved value is a compiler error in Rust. So let's continue speaking. Rust intends to be a language for highly concurrent and highly safe systems, which has inspired a feature set with an emphasis on safety control and other things like I already told you. Memory safety. Uh, Rust is designed to be memory safe. It does not permit null pointers, dangling pointers, or data races. Data values can be initialized only through a fixed set of forms, all of which require their inputs to be already initialized. To replicate pointers being either valid or null, such as in linked list or binary tree data structures, the Rust core library provides an option type which can be used to test whether a pointer has some value or not. Rust has added syntax to manage lifetimes which are checked at compile time by the borrow checker. Unsafe code can subvert some of these restrictions using the unsafe keyword. Yeah. So guys, that was all I wanted to tell you for now. I suppose you definitely enjoyed our video. You will definitely put your likes, subscribe on the channel, and write back that you like it so much.